Thank you. So my name is Björn. I'm about to talk about applied alerting philosophy, which I will explain in a second what that even means. First of all, I want to show off this logo. It has been in the keynote, so I sincerely hope you all know what that means. Some people are nodding. So that's the Prometheus logo. And if you have ever heard about me before, it's probably because I have been involved in that project for quite some time. The open source cloud native monitoring system. Obviously, it's also, no, not obviously, it's mostly also about alerting, and that relates to the title of this talk. I should probably also mention my employer, SoundCloud, put sounds into the cloud. Second thing, I sincerely hope for that you know what we do. I heard SoundCloud is pretty popular in Ukraine, so perhaps you all know. Also, quick update. If you're keen-eyed, you have spotted this alumni. As of last week, I'm not working for SoundCloud anymore. But they are so nice, they even give you alumni t-shirts if you leave them. There's also nothing bad that happened. I just went on for the next big thing, which is this company, which you might also know. They make this dashboard, but they also are very heavily invested in all things observability, and I'll work even more on Prometheus when I join them in June. For now, I'm officially unemployed, but yeah, as said, nothing bad has happened. It's all under control, and it's also not very relevant for this talk. I just wanted to not give you the wrong impression. I'm still at SoundCloud. Okay, the title of the talk, Alerting Philosophy, is coming from this document that some of you might have read. It has been out there. It's just a Google Doc that somebody put on view-only for everybody. Back then it went viral. It's still there. You can Google it. I also created a short link just in case. So this is, yeah, what is this even? And who wrote it? Who wrote it is easy. It is written by Ewaschuk, and he even writes it. He was a site reliability engineer at Google. I know him. I worked with him because I also was a site reliability engineer at Google for quite some time, many years ago. We worked in the same office for a while, so I can confess that what he writes here, based on, there's something missing, rather, based on my observation, this is not something he made up. It's not his pipe dream. This is really based on how Google actually did, and probably is still doing, alerting. And from that perspective, it's really insightful. I was so impressed by this take on distilling a philosophy from the way that our employer back then did alerting, that at SoundCloud, when I had to teach people how to do alerting, I thought, yeah, they should read this. They should apply this philosophy on alerting onto our own systems. And this is why I called an internal training talk, Applied Alerting Philosophy. And that was essentially a guided reading through this document. Now, many years have passed, so this talk that I give today, it has the same title, but it's pretty much evolved and refined and everything. And also, this document has changed, because if you look at it now, it has this nice yellow header, and it tells you the ideas in this paper form the foundation for monitoring distributed systems, blah, 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 which is a chapter in Site Reliability Engineering, how Google runs production systems. So what does that mean? It has become a book chapter. And it's way more refined, so Rob recommends you to better read the book. I still like to read the archaeological evidence that this has been around for a while. There's also a link to the Hacker News discussion post from back then. Also, I still kept the title of this talk because it's kind of a tribute to this inspiration that Rob gave me back then. This is the book. Here it is. You can buy it on paper. You can also read it for free on the web. This screenshot is just from the web version. You can just Google SRE book. You will get it. It's funny that you can Google Books, but yeah. Also, this is the third thing I sincerely hope for, that you all know about, at least the existence of the book, or you have read it. The term site reliability engineer already happened during this conference. It was also mentioned in the keynote, because our keynote speaker is a site reliability engineer, not at Google, but this is now a thing, and it has a very close relationship to DevOps. I mean, some people say site reliability engineering, I will now call it just SRE, implements DevOps. this is certainly a matter for discussion. I could give whole talks about that, or I actually have given talks about that, so you can look them up as well. So if you're DevOps, if you're running anything at scale, which is easy nowadays in the age of cloud computing, read this. It's very inspiring. You should always keep in mind that you're not Google, so things are different for you, but it's still very inspirational. And this is chapter 6, written by Ewaschuk, right? Sadly, it's not, no alerting philosophy in the title anymore. Probably was too cheesy for the O'Reilly editors or something, but it's certainly still in the text. Like the underlying truth is the same. So totally read it. Totally read the whole book. All the chapters are relevant. I just want to point out the ones that are most relevant to this talk. There is chapter 4, Service Level Objectives, SLO. I guess you all have heard that term and you all have a vague understanding. If you want a more precise understanding, there's the chapter. I'll just mention that quite often in this talk. And then there's chapter 10, which is practical alerting from time series data. The title doesn't really tell you so much about the gist of it because this is essentially describing the concepts behind Google's internal monitoring system. Or I should say Google's traditional internal monitoring system, because they have new ones now. I heard last time I checked with my former colleagues that it's still monitoring all the important services. It's called Borgmon. And yeah, it tells you about all those concepts behind that. And of course, you might ask now, what does it help me if I know about Google's internal monitoring system if I cannot try it out at home or at work? And Jamie Wilkinson, who wrote this chapter, he anticipated this. But how does that help you, our dear reader? And then he mentions all those new style open source monitoring system, Riemann, Hacker, Boson, Prometheus, and probably more by now. I mean, this book is from 2016, right? So, and in particular, Prometheus is very similar. The principles of variable collection and rule evaluation remain the same across all these tools and provide an environment with which you can experiment and hopefully launch into production the ideas inspired by this chapter. So great. After only 15 years, we can now finally do what Google has done before, thanks to open source. Okay. Now, there is another book. Site Reliability Workbook, nicknamed the second SRE book. This is just from last year, and I mean, the authors of the original SRE book were kind of thinking we should finally write a book about it, but who will get it, who will like it, we don't know. And a bit surprising, there was a surprise that it became a bestseller, essentially. So people loved it, and O'Reilly also liked it that so many people bought it, but now it's also available on the web. But also people asked, like, I am not Google, how does that even apply to me? Can you give more practical advice? Can you give case studies? Can you perhaps even mention some concrete examples how this applies to non-Google? And they heard you or us or whatever, and they wrote this book. It really exists. It's also for free on the web by now. And this book is, I mean, I like both books. I was also a tech reviewer for both books, so perhaps I'm biased, but you should totally believe me. This book has one chapter. This is essentially the blueprint for what I'm going to tell you, which is alerting on SLOs, alerting SLOs. It's all there, right? So this is so important. I mean, you can read it on the web, but as a tech reviewer, I got a few complimentary copies, and I have one left. So whoever asked the best question in the Q&A gets this as a gift. Giveaway, which was not on the Telegram. But anyway, you are here, so you can profit from it. All right, so this chapter is really important. We'll come back to it. So idea is now that you just read all of this and I stop talking, right? And then you can have the part, whatever. Now, you probably want me to talk a bit longer. So I will now explain the most important philosophical concepts from Rob's chapter or paper. And then we will dive into this case study, how we apply all of this very concretely at SoundCloud. And you can try it at home then. Okay, first concept. This is really important. It seems trivial, but that's often the case with important concepts. Symptoms versus causes. So Rob writes, this is a quote from chapter 6, what versus why is one of the most important distinctions in writing good monitoring with maximum signal and minimum noise. Okay, so what is that about? Symptoms, causes is pretty obvious. There are examples in the book, as if we don't know what that is, but yeah, we should probably look at it. Serving HTTP 500s or 404s. What is the cause? Could be anything. In this example, it's that probably a database server or all the database servers got a wrong permissions model or something and are now refusing connections. Okay, my responses are slow. Blah, could be anything. CPUs are overloaded by a BOGO sort. Or an Ethernet cable is crimped under a rack, creating packet loss. Okay, you see here already that causes are very fluid, could be anything. Symptoms are the ones that annoy our users. So what does that mean for alerting? We should actually go back to our old Apache server that runs somewhere, perhaps even at home or on some rented data server, data center. So back then, in the old days, symptoms and causes were still symptoms and causes, but we didn't have to think about it because if our Apache server is down, our site was down. Symptoms and causes were kind of the same thing. And this is why we kind of got used to alerting on causes. We alerted on the server doesn't ping, right? And that was the right thing back then, right? Nowadays, SoundCloud is not that big of a company. We run 1,200 servers. If one of them is down, the site is not down, right? All the time. Right now, probably 3 or 4 servers are down, or even more. We cannot just alert on server being down, right? So that's very important. If we alert on something like server is down or packet loss or something, we get alerts all the time, although our site is fine because we designed our distributed systems to tolerate certain errors, right? So cause-based alerting is really noisy. It gives me a lot of false positives. Now, causes are also very diverse, and we cannot even think about all causes. The most interesting or devastating outages are caused by causes that we didn't anticipate, because if we anticipate a cause, we probably have done something about it to mitigate it. We don't have an alert for Ethernet cable is crimped under rack, probably, right? We might have an alert on packet loss, okay. But I mean, the problem is causes are not predictable. So if we just rely on cause-based alerting, we might also not catch many important causes. So they have false negatives. They have all the bad things. So what we should do, we should alert on symptoms. Because symptoms, this is essentially what's written in our SLO or even SLA. Our SLO, if it's written appropriately, is the very definition of being up or down. So what I want alerts to directly match my SLO. If my SLO is I should not serve 500s and I serve 500s, I'm out of SLO and I can get an alert. So symptom-based alerts are avoiding false positives and false negatives. And I cannot get away without them because the cause-based alerts are noisy and also not complete. Okay, now I should probably define what alerts are. Pages versus tickets is another important concept. It's a bit weird because people have different terminology here. I come from Prometheus land, and alerts, according to Prometheus, is everything that Prometheus sends to the alert manager, which is another component in the Prometheus ecosystem. The alert manager then aggregates and routes and whatever and sends things to PagerDuty, which results in a page, or Slack, or email, or your ticketing system, or something, right? So alerts, according to Prometheus, is kind of everything. Confusingly, at least in the first SRE book, they call alerts what I would call pages, or we would call pages at SoundCloud. These are the alerts that require you to act immediately. Act immediately, alert or page. Everything in Prometheus has a label, which you can freely pick. We just decided at SoundCloud we used the severity label, and we could have called it page, but that would be too simple, I guess, whatever. It's called critical. It is delivered to your pager. And this is the one that should be based on symptoms. This is the one that should be actionable. It should only wake you up if something is broken. It should always wake you up if something is broken is the wrong word. If the users are impacted, right? That's the thing. Act eventually. This is the other type of alert. It's called a ticket in the SRE book, which I also like to call ticket at SoundCloud, but we also call it email alerts because most of the time it's delivered by chat or email. It should go to our issue tracker, but if Jira is your issue tracker, it's really hard because Jira is so hard. But yeah, I mean, ideally, those alerts go to an issue tracker so people can sign off. They are working on it. emails is really bad because nobody can sign off on emails. The target is that somebody acts on them eventually. That could still be symptom-based if you are like you're a company that processes a daily batch order of your customers. If that system breaks, there are like you have 6 hours time to wait for somebody to wake up and fix that, right? Just it has to happen in the one day. But often those tickets are based on causes. If a server is down, and probably you have some automation in place to restart it or bring it back or something. But if that all fails and the server is still down, you cannot just ignore it forever. At some point, somebody has to act on it, but not in the middle of the night, right? And you don't want this slap in the face, as we know it from the keynote. You just want to have your daily routine, and at some point, some person will look through all the servers that are currently down for unexplicable reason and deal with them. And that goes for that ticket. Cause-based alerts also have another important function. They should help you to investigate. Because this is what also we had in the keynote, perfect segue. You get a symptom-based alert, and it tells you essentially your system is broken. But what is broken? Then you need all your tools of diagnostic. We learned about traces and logs, but like in my opinion, many of those cases can be just, metrics are often enough. I mean, not the hard cases, perhaps not, but most of the cases, you can just look at metrics. You look at dashboards, and you see this curves look weird, it looked differently yesterday, and then you already have a hint. Ideally, you don't have to rely on your wetware to find this weird pattern. You might have an alert, and this could even be an informational alert that never notifies anybody. It's just there. You can look at it in Alert Manager on the Prometheus server, and some helpful developer put an alert there. If this RAM usage is higher than X, that's weird, right? It doesn't need to impact anybody, might not even be actionable, but if something is broken, this might be a lead to the actual cause and whatever. So those alerts all make sense, but only those page you. Very important to think about that way. Whenever you create an alert, think about it. Is it symptom-based? Is it actionable? Is it urgent? It all must be true to be a page and wake somebody up. So now symptoms is a bit wider defined than you might think. These are all quotes from the book I really like, all from Rob's chapter. One person's symptom is another person's cause. Weird, right? So this means we have multi-tiered systems, and if you're sufficiently big, you have multiple teams, multiple owners, and then you get something like internal SLOs. If I'm the database team, or I'm on the database team, sometimes one person is the database team, not a good situation to be in, but whatever. Then I have kind of an SLO with all my peer teams that use the database. I have an SLO like 99% of the time I should respond to all the database query in 100 milliseconds or something, right? And if my database has a problem and I'm not fulfilling that SLO, it's a symptom for me. For all the other microservices that use their database, it might not be a symptom. It's definitely not a symptom, it's a cause, which might or might not bring down their servers. They might have some graceful degradation or like whatever, backup database, or it might bring them down, but it's still a cause for them, right? So it's a relative thing. Everything is relative. Keep that in mind for in 10 minutes. Okay, not yet occurring but imminent problems. I bragged the whole time that a page should be if there's an actual user impact. That's not quite true. If I know I will have a user impact very soon, then it counts as a symptom essentially. Or sometimes you have this. From your monitoring, you know for sure this will crash in 5 minutes and bring the site down. Totally page then, and not in 5 minutes when the site is actually down. Perhaps you can even prevent that, right? It's fine, counts as a symptom. And a very special case of that is the zero redundancy situation, n+0. N+0, perhaps you've heard about it. At least there's a Wikipedia article about n+1 redundancy. It was a magic thing back at Google, right? Google operates in those terms at the data center level. Nowadays, with cloud providers and availability zones, you might have a similar mindset. So if you are really super serious about your availability, you want to be able to serve your peak traffic with one less data center than you have live. Even the biggest data center may disappear and you can still serve peak traffic. That's n+1 redundancy. If that's the case and you really mean it, that's your SLO. Your SLO is to have that redundancy. So if one data center goes offline and you are now at n+0, your users are completely happy and nothing bad has happened and nothing bad will happen unless another data center goes dark. And if that's part of your SLO, it's a zero redundancy situation. It's per page worthy because that's a new definition, right? So symptoms is a bit flexible. Always think about this. But like paging somebody because of packet loss is usually not the right thing. Okay, now also bragging about this immediate user impact, and then you cannot know about causes. You should check if there's an actual user impact or an imminent user impact. This might inspire you to think about Blackbox probes, because that's what Blackbox probes are, right? They are a kind of end-to-end test. They simulate real traffic. You send an HTTP probe to your very front-end layer in your service mesh, and then you expect a certain response. Great, right? I mean, that's true, but there's a bit of irony in it, because this diagram is really old. I put it from the bottom of my slide deck repository, because when back in the days nobody knew about Prometheus, people all asked me, so we have Nagios, why should we use Prometheus? Or they even were in that state where they said we have Nagios and it doesn't work, why will Prometheus help us? And then I told them, yeah, Nagios is this traditional host-based monitoring system, Prometheus is this modern service-based monitoring system. We're talking all about services and not about hosts. That's the hotness. But I also added this other dimension. I said Nagios is Blackbox. So this is, the contrast is not ideal here, but anyway, no changes required. That's written here. This is the old classical ops model. Developers write software, throw the binary over the fence, and then ops people have to monitor it somehow. So what can they do? They send probes to that binary and study the reaction, and then they have to find out if the service is up. And I said to them, this is so old style and so bad. What you need is white box monitoring, which requires instrumentation. We have learned that in the keynote. I'm so thankful for this keynote. Instrument everything, right? Not only for metrics, for everything. Tracing, logging. Instrumentation is what you need to do anyway, and this is also what the developers need to do, and this is like totally fine DevOps pattern, right? Everybody works together, and developers have to think about monitoring and logging and tracing and everything. I mean, I can brag on like this forever. This is just the hotness, right? But now we realize for the symptom-based pages, perhaps Blackbox probes are not that bad. So for one, we would like to see something here, which is modern and service-based and still whatever, right? And I mean, there is something like this. It's called the Prometheus Blackbox Exporter. So you can totally add this capability to Prometheus. It's just an additional moving part, and you kind of notice this was not the original idea how Prometheus works. But still, like, this is possible. And we can also ask the blue book, right? That is what we want. I have a quote here, but just a sec. Okay, the quote is, so this is what Google does. We combine heavy use of white box monitoring, with modest but critical uses of black box monitoring. And this is exactly what we do at SoundCloud. Like, we do black box probing, but all the pages and all the meaningful pages are usually, even the pages, are triggered by white box monitoring. And also, I told you how important cause-based alerts and alerts just, or metrics just to find out what's going wrong, or even traces and logs and everything. So you need the instrumentation anyway. And if you have instrumentation in place, why not make the best use of it? Okay, still, black box probes are important to a certain extent, right? So, what are the limits of black box probes? The one is directly from Rob's chapter. For not yet occurring but imminent problems, black box monitoring is fairly useless. The words of Rob, right? So that's the problem. If I have this nice case where I know in 5 minutes my site is down if I don't do anything, this can only be detected by white box monitoring, because the black box probes are all succeeding, because they see the real thing, right? If the site is still up, if I'm an n+0 redundancy, the black box probes will all be fine. Okay, the second thing is, it's something that is, I think, not in the chapter, but that's really important for me in my opinion. It's this whole long tail problem. I mean, I think 2 or 3 years ago, people started to many people knew that before, but it was like a common trope that everybody was talking about long tail latency. 99.9% latency is all of a sudden really important in microservice architectures, distributed systems. So it would be a whole talk of its own to explain that, but just do the math. How many probes do you need to safely measure your 99.9% latency? It's something like thousands, right? How long do you need to send thousands of probes without overloading your system just by the probes? Long tail problems are really not easy to measure with black box monitoring. And that also goes for low error rate that are still above your availability target. If you want 3 nines, 99.9% availability, 0.1% errors are kind of fine. We'll talk about that in a second. But if you have 0.12% errors, that's not fine anymore. Now measure that, right, with probes. Again, you need hundreds of probes to even get an idea that you are slowly burning your error budget. So all of that is kind of problematic with black box probes. So, and then also, I said black box probes simulate real user traffic. Actually not, right? I mean, my favorite example is our end-to-end SoundCloud black box probing. The probe simulates going to the site, opening a playlist, playing a test track. And the test track is, you guess it, it's beep, right? Because that has no copyright implications and everything. So nobody ever wants to listen to our test track. But if now a new rap battle is going on, we have a track on the site that is suddenly super viral and everybody wants to listen to it, literally tens or hundreds of millions of people. And let's assume it's in an S3 bucket that somehow gets overloaded. And I'm not claiming that S3 or SoundCloud works that way, but for simplicity, let's assume that S3 bucket gets overloaded and our test track is in a different bucket. The test track plays fine, the black box probe is happy, but millions of Earthlings are unhappy because they can't listen to that rap battle. Yeah, so you want something that is closer to reality. And here we come to this one person's symptom is another person's cause thing. I made this little diagram. So, is that still working? This is a backend service or multiple backend services. That's a front-end service somewhere in a microservice, like a little part of a microservice mesh. So now for this backend service, if that backend service fails, it's kind of a symptom of the backend service, right? For the front-end service, it's a cause. The front-end service, if it's instrumented, then Prometheus can scrape it, or any other white box monitoring system, and Prometheus knows exactly the percentage of errors, knows exactly the latency. It can calculate your 99.9% latency, and it knows all the traffic. This is essentially probing with real user traffic, right? If you can instrument the front-end service and then monitor the back-end service. And that's essentially what I want to show you in the case study. It's an application of this pattern, this idea. Alerting on SLOs at SoundCloud. As I said, it's essentially following chapter 5 from this nice book with a few additions. We need a front-end tier and a back-end tier, and we need the frontiest front-end tier we can have. This is from our tech blog called the Backstage blog. There's a link. Later you can look at the slides and click on that link. We call this traffic. It's a traffic layer. It gets the traffic from the internet, mostly from the CDNs, because we stream a lot of stuff. It's essentially just a collection of HA proxy instances, and they route or proxy the traffic to something on Kubernetes. This first layer of our microservice mesh is called BFF, which is a common microservice pattern. I think it was even invented at SoundCloud, backend for the front end. Doesn't matter so much here. You can even Google it. But this is the kind of front end here we are looking at, taking internet traffic, sending it to our Kubernetes cluster. We call this thing Ampelmann, is our nickname. You might know those Eastern German traffic light people, because we're from Berlin, and it's so iconic for Berlin, is what we call them. But anyway, so HA proxy is our front-end layer. It's open source. It even has a sense of metrics. It's called stats, but it's not instrumented for Prometheus. You have that quite often. Something you want to monitor is not instrumented for Prometheus, and then you could either instrument it but that would be quite invasive. Or you use this very familiar, we call it an exporter pattern. You create a little glue binary. The glue binary is scrapable for Prometheus. And whenever you scrape it, it goes to the thing it should monitor and ask this thing in the way this thing understands for its metrics. And for HA proxy, it's called the HA proxy exporter. It's in the Prometheus org. But if you want to find an exporter for your system, just look on the internet. Like there are, so on the Prometheus project page are also like, I don't know, hundreds of exporters for all kind of thing. So HA proxy exporter, very tiny little binary, super helpful, gives you nice Prometheus-like metrics about HA proxy. So now, if you have never seen PromptQL, don't despair. It's an own expression language, and to make things worse, also referring to the keynote, it's YAML, and then in the YAML you have embedded the PromptQL, and it's not code. I mean, PromptQL is kind of code. It's Turing complete, but yeah. Anyway, so this is a rule. So for complicated calculations, you can tell Prometheus to pre-calculate things, and then there is a naming convention, but this blue string, you can name it whatever you want. It's just following the convention. This is HTTP errors per response. It's a ratio over 5 minutes. And this is how it works. The HA proxy backend HTTP responses total, that's the thing you get out of the HA proxy exporter. It counts requests and it labels them by status code and by backend. Backend is an HA proxy term, which nicely fits our definition of backend here. So you sum it up over all instances by backend, you take a rate over 5 minutes, and what you get is your fleet-wide error rate per backend. I mean, you have the 5xx, you divide by the total sum of everything. I should mention that. Anyway, if you are not familiar with that, you don't have to understand it now. It calculates the error rate over 5 minutes. So now the owners of those backends, they can submit their SLO. Like let's imagine we have an API v4 here. We don't have an API v4. I couldn't disclose like internal product names, so I used API v4 as something we don't have, but let's imagine it exists. 0.1% error rate, 99.9% availability if you want, is the SLO. And then we have the legacy API v3. We still maintain it for selected few customers, and we have a somewhat relaxed target, right? So users or owners of those backends put the thresholds here, and then we are almost done, right? We just alert if that 5-minute rate goes over that threshold, right? People are nodding, but I don't want you to nod because every like 5 minute spike of 0.12% errors will send you a page. And that's actually not what we want because, like, I mean, I should mention my SLO definition wasn't complete because the SLO is not to serve only 0.1% errors at any time. Usually you attach a time span. Like I mean, it depends on the nature of your service, but what we at SoundCloud do, we say over a month, we want to serve 99.9% of our requests in time and correctly. I mean, that's not the real thing, I'm making this up, but it's somewhere in this area, right? So let's say you have a monthly availability target, right? And then essentially to reach that, you want 0.1% of errors averaged over a whole month. That's sufficient, right? This is also leading to this whole concept of error budgets, which I think I mentioned without explaining it, but you might be familiar. If you are allowed to have 0.1% errors, or 0.1% downtime, or whatever you call it, in a month, you have like 50 minutes of downtime, that's fine. And that means you don't have to design for anything better, and if you are better, you can use it for risky product launches or something. It's called the error budgets, they're like whole talks about that. And our alerting should be based on burning this error budget. If I'm far away from like having 0.1% errors over a whole month, I should not get paged. And having 0.1% errors over 5 minutes is totally not a month, right? So we want something that is less noisy than that. And now we go to this chapter, alerting on SLOs. And this chapter is super nice. It goes through various approaches you could take. And then it finds out what are the pros and the cons, and then it refines this approach. And it goes through altogether 6 iterations. And I mean, I would love to explain them all to you, but we have only 10 minutes left. So I jump to the final thing, which is the multi-window, multi-burn rate alerts. And this is kind of, wow, it's so good. So parts of that we already had at SoundCloud, and parts of this is what I just stole from the book to apply to our systems. Let's start with the multi-burn rate. there are burn rates. There are weird factors. Let's start with 1. Factor 1 is almost the easiest. This means if you're burning your error budget as quickly as you're supposed to burn it on average, that means exactly as fast. 0.1% over a whole month. It's just barely okay, right? So now, if you do this for 3 days, 3 days is 10% of a month, you have burned 10% of your error budget. And I mean, you don't want to be at that edge all the time, right? So if this is actually happening, you have burned 10% of your error budget in 10% of the month, you want a ticket. Nobody should get paged for that. It's kind of barely fine, but you want to find out. I mean, this is not okay to be there all the time, and somebody should work on it eventually. But now let's imagine you burned it quickly, more quickly, like factor of 6, 0.6%. If you have 0.1% as an SLO over 6 hours, you can do the math, it's 5% of your monthly error budget. In only 6 hours, right? If that goes on like that, you will be out of SLO very soon, and then you cannot catch up, so you want to page, because this is like hours. And the next hardest one, 14.4, is like weird, but if you have 1.44% of errors over an hour, it's 2% of your monthly budget. 2% is a nice number again, right? That's where this is coming from. Page, of course. So, okay, so this is the multi-burn rate approach. You just create multiple alerts with those different factors. You can put them all into one PromptQL expression, and the nicest thing is that in this book, they use PromptQL. Because they realize you want to try this at home, there's no point in using their internal monitoring system, so they use the open source monitoring system that is most closely related from a like semantic perspective. Also, this is like, it's just a perfect fit to apply kind of Google alerting philosophy to your own system. Just use Prometheus or use PromptQL. I mean, there are millions of integration points, as you have also learned in the keynote. It has, yeah, kind of people converge on this way of alerting. Prometheus, just the proverbial example. So, okay, very quickly, here you see the first 14.4 factor. 0.001 is 0.1%, just as a ratio, not as percent. This is factor 6. You have an OR. If any of these happens, it's a page. Here you have no factor, like factor 1, and it's a ticket. Okay, great, right? This is already what we want. Now there are 2 things, 2 concerns, I guess. The one is not a valid concern, and the one is a very valid concern. The not valid concern is what people often think. I have a 1-hour window for my error rate, that the earliest the alert can fire is after 1 hour. That's what like naively people might think, but that's not true. I mean, it's kind of easy, but you have to think about it. Imagine 59 minutes of no errors at all, and then 1 minute of 100% errors, total site outage. What's the average percentage of errors? It's kind of 1.5%. You can do the math. So that means if I really have 59 minutes of no errors and then my site goes down, I have 1 minute of 100% errors, it will take only a minute for my 1 hour window to fire. And this is this graph, right? So if I have total site outage, 1 minute, and this is as fast as it could be, right? A human needs 2 minutes to wake up and 3 minutes to start up the computer and work on it. So you don't need anything faster. For lower error rates, the alert will be faster, going to almost an hour, because this is 1.44% when this alert will not fire at all because it's this factor, right? But then the other alert takes over, the factor 6, which is a bit slower, but it's also slow burning of the error budget is fine. And this is the ticket thing for the long-term slow burning of your error budget. So this is kind of perfect because it will never fire when you're not burning your error budget pretty fast. And it will also never miss burning your error budget. It's kind of just the right time frame. It's all good, except one thing. The one thing, we have to look at a real timeline of an alert. Let's first look at the blue line, this one. So this is the actual error rate, right? Reality, if you want, if that exists. So 0, t, 0 minutes, all is fine. At t plus 10 minutes, an outage strikes. You have, for some reason, 15% of error rates, whatever. Some recs went down or something. This is lasting for 10 minutes, and then the outage is over, for whatever reason. Perhaps it was just good luck, or somebody did something about it. OK, that's the blue line. Now let's see how the error rate over 1 hour, how it evolves. The outage strikes, so this goes up and up and up, the average over 1 hour, and after only 5 minutes, you hit the 1.44% threshold. That's good, right? I mean, 5 minutes is as fast as we want it to be. So let's imagine an engineer wakes up, fixes the outage. That's probably why 5 minutes later it goes down, because that was an awesome engineer, wakes up, realizes what's going on, and fixes the outage. I mean, uncrimps the Ethernet cable or whatever the real reason was, and then it's good. So now you want to go back to bed. However, as long as this little error spike is in your 60-minute window, this orange line will stay above the threshold and your alert will continue firing. Now, I don't know what paging system you use, but like PagerDuty has this default semantics, you act an alert, and then it stays acknowledged for a day or something. You can configure that, but I think it's a day by default. So the page will not wake you up anymore. You could just say, sure, I fixed the problem, I go back to bed. This is good, unless, let's say at t plus 40 minutes, the same outage happens again. And you again get a high error rate. The same alert that is still firing will fire even harder. But there's no notion in PagerDuty, this alert is now firing even harder, and you get a page again. You just don't get the page, right? It's act for a day. So this is really bad, and to not have engineers do this, I mean, the engineer essentially has to watch this for an hour, which is bad, right? You want this alert to stop firing as soon as the outage is over, or at least not after an hour, but like 5 minutes. And now this is the really simple but ingenious idea from the book. You also take into account the error rate over 5 minutes, which would be way too noisy to alert on it, but you alert if both 5 minute and 60 minute are above the threshold. And, logical and, right? So what happens? The green rate goes up very quickly, but you only alert when also the 60-minute rate is up. And once the outage is over, the green one goes down very quickly, and then the alert stops firing. So the alert only fires in this red area here, which is perfect, right? Quick reaction, and it also quickly stops firing. And you can go to bed, the alert will resolve, and PagerDuty will page you again once the alert fires again. Hopefully not, but if it happens, you will surely notice. Perfect, right? We're done here. This is very nice. This is how it looks in real. This is really from the SoundCloud, almost real. I just did a few things. Ampelmann error budget burn. This is the 14.4 and 1 hour thing. The 5 minute window is here, again 14.4. There's a for clause, which I will explain in a second. And then we have red runbooks and severity critical, it's all there, right? So now you need more alerts for like factor 6 and rate 6 hours and so on. You can see this in this table. 1 hour, 6 hour, 1 day, 3 day. This is the short window. And this is the burn factor, which you put into this alerting rule. And this is the percentage burned as before. The only thing that's left here is the for duration. That's new. That's something that in the book, they tell you explicitly not to do. What does this mean? The for clause in Prometheus is that an alert has to fire continuously for this duration, then you get the page. Before that, it's blocked. And they say this is just like creating a delay. You shouldn't do that. The truth is, and this is where I kind of don't agree with the book for a change, if you have like normal traffic going up and down, but you always have significant amount of traffic, this is all true. But if you, for example, have a whole data center drained, it has been drained for a week, and then you send traffic to it, and then you get the first 100 requests because it has to warm up, give you 10 errors. That's like not a big deal, right, if it normalizes later. But 10 errors out of 100 is 10% error rate, and these were the only requests at that moment that this alerting system has seen in a week. Then all these alerts will fire. All the pages go off, right? It's pretty horrible. And this is just statistical noise. You could do some advanced statistics on it, but this for clause, in my opinion, is super easy to do and super easy to understand. You wait for 2 minutes until the caches have warmed up. It delays your page by 2 minutes, but you have a human delay in it of a couple of minutes. It's probably fine, and it solves your problem. So this is a significant deviation from the book. If you read it up, that's how we do it at SoundCloud. Final thing, I have 30 seconds for the final question. Who gets the page? This is really important, because that's, again, this old ops style thing where you have this PagerMonkey team that gets all the pages and has no clue what to do about it. Rob also writes this in the alerting philosophy, you must react to pages in a competent way. Otherwise, it doesn't make sense, right? So you want the pages to go to the person who is most qualified of dealing with that. And in our case, that would be the owner of the backend. Give me 30 seconds, okay? So at SoundCloud, we label all systems by a system label. Unfortunately, HAProxy has only a backend label, but we can, I assume the backend is identical to the system. In reality, it's a bit different. It has multiple components, but Prometheus has functions like regular expression, label replace, whatever. You can all translate that. Oops. So everything at SoundCloud has a system label, works perfectly for Kubernetes, where you can freely label everything, perfect match. And then we have a little file where for every system, we like map the owner, and from that file, we create a routing tree in Alert Manager. This is very sophisticated. I will not explain the details. You can read it up in the documentation. This is the actual routing tree graphically represented at SoundCloud, which is like a 100-something engineer company. You see this gets complicated, so you're not supposed to write this YAML yourself, as we've learned in the keynote. This is auto-generated from that mapping file, but it like maps to severity and to the owners, and everything that's not mapped goes to me, essentially. All right, so now we had the full life cycle. SLO-based, symptom-based, pages, not noisy, always right, and going to the right owners. Thank you.
Now we have 5 minutes for your questions. Okay.
Thanks for the speech. I wanted to ask, what do you think about the predictive alerting, and is it practical? Have you ever used it?
So predictive alerting, this question was on the microphone. I don't have to repeat it. I'm so used to repeat the questions at conferences. Okay, so I would just apply this criterion. Is it imminent? Obviously, if it's predictive, it's not an actual user impact at that moment, but does it qualify for it's imminent? And like people often have this A word, anomaly detection, right? And then often alerting vendors tell you, you don't have to think about this at all, we will solve it all with machine learning. And I'm highly suspicious of that, because you want to understand, you anyway need to understand your SLO, right? And if you have an SLO, it's easy to alert on, you don't need machine learning. Predictive is, can I predict that I will now be out of SLO very soon? I would say it depends how paranoid you are, how it's always a trade-off of noise or not. If it's reliable, sure, but it should really be, how to say that? If you should understand what you're doing. Machine learning is often something you don't understand, is inherently noisy because it will alert on obvious things that are false positives. But yes, as long as it's a reliable way of knowing that there is an actual user impact imminent, it's fine. But this is the important question you have to ask.
Thank you.
Thanks for report. So we get metrics, we receive notifications and alerts. Have you experienced to use any tool that automate resolve alert cases?
So auto mitigation is essentially the keyword, right?
Yeah.
Yeah. So yes, sure. This is a different topic. It's kind of related to alerting philosophy, because I showed the runbook link, right? So we are pretty adamant at SoundCloud that every alert should come with a runbook that helps the receiver of the alert to deal with it. And if the runbook says, open an SSH session on that server, run kill all -9 something something, then wait for 5 minutes, and if it's essentially a script, the runbook, then this is a good hint that what you asked for, you should do that. You should have a script doing this. Now you could do this with Prometheus, like an alert could also be sent to an webhook, right? You could say, I create a little API that Prometheus calls when it detects an alerting condition. You could do this. I would still be suspicious because it's a bit indirect. Like, it's often a good idea to take one step back if you can solve this without alerting. Like, often this one system that goes down all the time kind of knows about it. You can build it into the system or have a little sidecar that restarts the system if need be. But I mean, if nothing else helps, you can totally do this and have kind of an alert that triggers some auto-remediation. But yeah, if the runbook looks like something that has to be consumed by a machine, go for it. If the runbook looks like a human being, or perhaps someday an AI DevOps agent will do it, then yeah, then it makes sense for a human to intervene and follow it. Okay, so I think we have no time for other questions. I'll be around, right? You can ask me. By the way, this is our Backstage blog. There should be an article in a week or so about exactly this topic, Prometheus homepage, and this is where you find my talks, and at the very end I will put these slides up very soon. Okay, thank you.